So, good morning, one and all. In the last lecture, we have discussed how to analyze this indeterminate truss. First is the to find out the support reaction. Before that, we can check the degree of redundancy. Here it is observed that there are two members, and if you remove any one member, the triangle not disturb, and that's why degree of redundancy is 1. Or we can find out using m minus 2j minus 3, the value of degree of internal redundancy is 1. Okay, and then we can find out the p force analysis. After finding the support reaction, find out the p force analysis, then remove this 30 kilonewton load and apply the unit load in the member which is considered as redundant, and then again analysis, that is k force analysis, then tabulate the result and find out the correction factor, that is equal to minus summation of pk square divided by e divided by k square l divided by a, and then we can find out the forces in all the member. Okay, so let us start the another problem similar on the same basis. One triangle is given. So in this case, what is given? Analyze the truss loaded and supported as shown in figure. Calculate the vertical deflection at joint B. Here at joint B, we need the vertical deflection for the given truss subjected to 22 kilonewton load and 12 kilonewton load. Okay. What is the expectation? Expectation is the support reaction, sketch P force analysis, K force analysis, and the vertical deflection at B. So let us start. First of all, this is the determinate truss. Roller is there and hinge is there. That's why reaction components are 3, equations are 3. That's why R minus E is equal to 0. Similarly, M minus 2J minus 3 is also equal to 0. Okay, because 3 joints are there and 3 members are there. So 2 multiplied by 3 minus 3, it is 3, 3 minus 3, 0. Okay, so here the given distance 3 meter, 4 meter and 5 meter. That means the length of all the members are given. So from this we can find out the theta. That means the angle made at A, angle made at C, and angle made at B is 90 degree because it is the 3, 4, 5 triangle. That's why this is 90 degree, and you can find out this angle on the basis of when we draw the vertical line, and then find out the sine theta is equal to this divided by this, and cos theta is equal to, we can see that this divided by this, we get this angle and this angle. Okay, so the angle is already calculated. Theta at A 53.13 degree and theta at B, that is equal to 36.87 degree. Okay, then we can find out this distance and this distance. So A to say point D, A to D is equal to say horizontal distance, that is equal to 1.8 meter. This is 1.8 meter because this distance is known. We can find out this distance. Okay, so sine theta is equal to this divided by this. So we get the y, and cos theta is equal to horizontal, that is the adjacent divided by hypotenuse. So we get the value of this. So it is 2.4, vertical distance is 2.4 and horizontal distance is 1.8 meter. Okay, this is the step number 1. Then step number 2, we can find out the support reactions. So summation fx is equal to 0. In x direction, HA is there and external load is also there. It is 12 kilonewton. So HC is equal to 12 kilonewton. Then summation Fy is equal to 0. RA plus RC is equal to minus 22. And then we can take the moment at point A. We get the value of RC. Put this value of RC in equation number 1. We get the value of RA. So similarly, this is the value. RA is equal to 8.32 and RC is equal to 13.68. Then P force analysis. For P force analysis, we can draw the diagram. Okay. Again, here it is observed that at joint A, there are two unknowns. At joint B, two unknowns, and at joint C, two unknowns. So Either we have considered joint A, joint C, or joint B. There is no issue. So first of all, we have considered the joint A and apply the two equilibrium equation. Summation fx is equal to 0, summation fy is equal to 0, and we get the force in the member AC and the AB. Right? So this is the joint A free body diagram, and we get the force in member AC. It is positive, that means tensile 6.24, and force in member AB, it is minus 10.14, negative, that means it is compressive. So then we have considered joint C. This is the joint C. Again, we have applied summation Fy is equal to 0 in y direction. This y component is there, and this y component is equal to FCB sine 36.87 plus RC, that is 13.68, is equal to 0. We get the value of force in member CB, that is minus 22.80 kilonewton. Okay, so here P force analysis is over. This is the diagram showing the P force analysis. Okay, then to find out the deflection at B, replace all the forces, external forces, and apply the unit load. We need the vertical deflection, that's why we need apply the 1 kilonewton load in vertical direction. This is my assumed direction, 1 kilonewton load. Okay, and again find out the support reaction SC, RA, and RC. Then find out the forces in all the member, considering the joint A, joint RA is equal to 0.64 and RC is equal to 0.36. Okay, so joint A, again repeat the same procedure. Summation Fy is equal to 0, summation Fx is equal to 0. We get the force in member AB and force in member AC. Similarly, we have considered the joint C, and again summation Fy is equal to 0 in y direction. We get force in member CB, that is the inclined member, is equal to minus 60 kilonewton. Minus sign indicate the compressive force. And this is the K force analysis diagram. Okay, this is the K force analysis. Then step number 4, tabulate the result. There are three members AB, AC, and BC. P force analysis, 2 are minus 1, that means the compressive, and 1 is positive, that means the tensile. K force analysis, same. Then length, it is already given 3, 4, and 5. And AE, the value of A is given, E is given, then A multiplied by E, convert it into kilonewton. So this is 2.2 into 10 raised to the power 5. Then PKL, P multiplied by K into L, that gives the 94.65, and divided by AE will give the deflection at B. Okay, this is the simple problem we can easily solve. Then another problem, calculate the vertical deflection at C. This problem also can be easily solved. Here the load is applied only at the, we can say that the free end. This is the cantilever truss. Okay, so no need to find out the support reaction. You can start from the joint C. When we have considered joint C, there are two unknown, and you can find out these two unknowns. But before that, you can observe the truss. It is observed that at joint B, there are two member which is in the same line, horizontal line. That's why force in the third member will be 0. So force in this member is 0. Now, when we consider the joint D, again, these two members in one line, this is already 0, and that's why force in this member is also equal to 0. That's why you can find out the, once you find out the force in member BC, we get the force in member AB because it is equal and opposite. Similarly, when we find out the force in member CD, it is observed that these are two 0, and that's why this is the force in member equal and opposite. Right? You can directly find out the force. This is the P force analysis. Then we can find out the vertical deflection at C, and that's why we, instead of this, we have replaced this and apply the 1 kilonewton load and repeat the same procedure, and we get the again forces in all the members. And then after that, we can find out the PKL divided by A. This is the analysis. of truss for the vertical deflection. Okay, this is about the unit number 3, analysis of truss. That is the first we can find out the we can say that the uh, deflection, and second is related with the indeterminacy, and that is the redundant truss. We can find out the forces in all the member. Thank you.